Hello, I'm Stefan Greber, I'm the project leader for lxd, and this is another release live stream. So, lxd 5.4 has been released last week. Did the actual release on Friday, so a day late because it was a very busy week for us with lots of meetings and stuff. And then the announcement was kind of polished and published yesterday. Uh, Unlike the past couple of releases, this release actually has new features, which is quite nice to see. Not like some of the features are kind of the basis for other features to come, so we're gonna be seeing some of that. But it also comes with one major new feature. So just before we go into any of the usual demos, I figured I would start by going through the announcement itself, and that means starting with a upgrade node. So this is something to be careful about. If you are running lxd currently and you have virtual machines, upgrading to 5.4 is going to require you to restart those virtual machines if you want lxc-exec and lxc-file to keep working for you. That's because we noticed a bit of a screw up on our part in the implementation of the communication protocol between lxd and the lxd VM. Because we're using a socket type called vsock to do that, which behaves in much the same way as like IP and NTCP would normally do, but don't actually require the VM to have working networking. It effectively uses shared memory between the host and the virtual machine to establish sockets. That's super convenient, it's great, it's high bandwidth, we really like it. But it's a bit unusual, and we've had to effectively tweak Go on both sides to let us consume that as a normal network socket. And also because of the way security works on vsock, it's possible for any user on the host to connect to any vsock of any guests, and it's possible similarly from the guest to access any vsock on the host. So we're effectively treating it as an unsafe channel, and so lxd uses TLS on top of it. So we effectively run it exactly like a normal public REST API, where we do TLS with server and client authentication going on it. And that's how we've always done it. So this particular issue we run into is not a security issue. The problem was actually we're doing too much TLS. So we're effectively doing a second TLS layer on top of the first one. By accident, just by using some Go functions. So we fixed that now, which means there's no more, like the overhead for communicating with the agent is much lower because we're not doing crypto twice. The downside is there was no good way to detect whether a guest was on the new code or on the old code. So moving to 5.4 requires a reboot of the guest so that they can get an updated lxd agent running, at which point communication will function again normally. So that's something to keep in mind. Hopefully not a super huge deal. Like we know that lxd VMs are still kind of the beginning of their adoption curve. A lot of our users are not actively running those, and those that are probably can deal with a quick restart of those VMs to just pick up an updated agent. All right. So with that out of the way, now let's look at the new features. The first one is support for load balancers. We've had something pretty similar in lxd for a while called network forwards, which lets you take one single IP address and then, based on the port, point it at different servers. This is a bit different because the load balancer also lets you have multiple backend servers for any specific port on the load balancer. Then we've got work on the new bidirectional vsock interface. That's actually what caused us to notice the TLS issue I just mentioned. This work in this release is mostly invisible to users. It might just lead to devlxd working a bit better inside of VMs than it would in the past. But it's also going to be the basics for a new feature in the next release, which is going to be the ready state. It's effectively the ability for a guest to signal to lxd that it's now effectively ready, not just started, but that whatever service it needs to start and operate in there is now ready to go. So we needed that communication channel be available for this feature to be buildable. So this release we introduce the change in the communication channel with VMs, so that next cycle we can, or the next release we can do we can introduce that new ready state. Next, we've got a reworked storage documentation. This is not particularly tied to any given lxd release because we also tend to backport those changes. But it's to highlight that our storage documentation has been updated and is better structured and hopefully makes a lot more sense to everyone now. Then we've got more storage changes. In this case, it's mostly kind of making things more consistent in our storage configuration. It's been a bit of a, yeah, while doing the documentation, we wrote down that, oh, storage pools have configuration on storage pools allows for setting the default value of configuration keys on top of storage volumes by using volume dot some key name, and then whenever a volume is created on the storage pool, the matching keys will be set on the volume. We documented that, and then that wasn't actually strictly true. Some of those keys were just plain missing. Some others were not quite behaving the way we were intended for them to behave. So we've cleaned all of that stuff up in this lxd release, and it now behaves the way we intended for it to work. Which is, yeah, you set config keys on the storage pool, and if the config key is named volume.something, then that key will be set on any new volume being created. And the last feature we've got in this release is the addition of project support to the lxd-benchmark tool. You might have noticed I actually went through that particular tool in the previous video on this channel. So yeah, that's kind of as part of playing with it again, that we added support for support for projects to it. All right, so that's kind of the overview of what's new in this release. Now let's switch over and do a quick demo of those features. So switching over to a terminal and going back up. The first thing we're going to want to show is the bidirectional, it's the load balancer feature of the load balancer. So should be in a demo project here with just a few instances running. I am. Okay, good. I still haven't copy paste. I'm effectively running on my home cluster here. I've got, there we go, an IP address that's currently unused. And just as a reminder, because I might have forgot to mention it, the load balancer feature only works with other networks at this point, mostly because there's no good way for us to do that kind of load balancing on pure Linux firewalling type mechanisms. We'd need to use something like proxy to allow for doing that on normal hosts. So currently this is restricted just to other networks, which is what I'm using here, so that works out. The first thing I'm going to do is create a new load balancer. So you can do lxd network load balancer create, and then the IP address of the load balancer. So in this case, it's going to be 243. Oh, and the network name, which is called default here. Okay, so that's created. I can see that my terminal is now seeing that something has changed. This IP address exists more than it used to. It's still not actually pinging or anything, but it's, yeah, it's at least clearly been defined somewhere. And what we'll then do is I'm going to use the edit command because it's slightly more visual. So edit the load balancer. Can give it a description. And then unlike a network forward, we've got both ports and backends. So it's kind of a segmentation there. In this case, what we're going to do is define 3 backends. As you might recall, I've got 3 instances running. So I'm going to be defining the first one as U1, and then the address for, so target address for it would be 10.22453. Can give it description too. Okay, so that's U1. I'm just gonna be copy pasting that for U2 and U3. That's U3. There we go. Okay, So I should be able to actually save that, and it won't have done anything because I just defined a bunch of backends, but there's nothing actually consuming those backends at this point. Let me just resize things a bit. There we go. So now what we can do is technically one of two things. I'm just looking up this thing. Okay, yeah, it's actually, I was just checking what the config options are, see if there was a kind of default or anything we could do there, but no. So we're going to be defining ports. In this case, it's again a list, and I'm going to be doing protocol TCP, listen port, and so we just want to, for now we just forward 1, 2, 3, 4, and target backend. And this is a list of the backends we want to forward to. So I could just do U1, that should work fine. Whoops. All right, that's slightly more structured than I remembered. This is an actual list. Okay. So now if we try accessing the load balancer on port 1, 2, 3, 4, it's saying connection refused. If we go in U1 here and start a listener on 1, 2, 3, 4, yay, that works. So, but that's also a bit pointless because what I just did here I could have done with a network forward. It's simply like, using address, specific port goes to a specific instance. That worked just fine even before any of this. So I'm gonna be running terminals on all 3 instances. So get U2 and U3 and run netcat on all 3 of them. Okay. And now I can go back here and let's say I want let's put all 3 file. So save all 3. And then if I netcat again, we can see it connected to the second one. Okay. Try that again. Same it went on the third one. Try that again, put on the first one. Try that again, it just fails because none of them are listening anymore. So that is a load balancer. It works as expected. The nice thing is you get to actually do it per port. So now if you wanted to define, I don't know, it's called HTTP, TCP, and we put, I think we can do multiple ports. So we can do those 2 ports, and we only want those to go to U1 and U3, save, and we're done. So it's pretty flexible. It lets you define all of your backend servers, and then on the front end, define what ports go to which of the backend load balancers. Okay, so that was load balancers. Next feature would be the bidirectional vsock interface. Not really something I can show. Let's actually have a local VM running here. That should work. Yeah. So that's a normal lxd VM. We can see that I'm inside of the VM through the agent here. And we should be able to see that this particular agent, if we go look at its sockets, oops. Yeah, that is listening on some sockets. It doesn't really help us a lot because we don't know exactly what any of those are. But it's communicate, like the agent itself is listening on vsock. That's how the lxd-exec command got into it. And now the difference that it can also reach out to the host. One thing that does that is the devlxd API. So if you use this and then we access, I don't know, search 1.0, and install kernel. Prior to LXD 5.4, accessing the devlxd API from within a VM would just be handled by the agent directly. So the agent had static metadata on disk that it would read on startup, and it would then return answers on it directly. That's different now. Now when you query the lxd API, this goes directly to the host and is handled by lxd in the exact same way that it would do a container, effectively. That might actually be something we can see. I did not actually try that, so let me see. So if I, on my host system, if I run lxd monitor pretty, that should show me all of the debug details for any query. So now if I do it in the VM, does it actually show anything? No, it does not. It just oh, it's because I'm not looking at the right cluster. Oh, I need to look at local. That will help. Oops. Okay, so we can actually see that we do get that we don't see a lot of details, but we can see that it matched the certificate of the client. So it confirms that those queries inside of the guest now go actually outside of the guest to the host now answered there. At this point, there's not really much more that you can see than this. If we did our job correctly, you shouldn't actually notice anything. And in the next release, we get to actually start building on that and adding more communication between the lxd agent inside of the guest and lxd itself. All right. Next, we've got the reworked storage documentation. So for that, I will actually switch back to the web browser. And we're just gonna look around here. So that's the new storage kind of homepage in the documentation. So that's the overview that we had before already of the different storage drivers and what kind of feature they support. But now you also have per driver pages with a lot more details and kind of more similar structure in between them. So that makes it easier to go look at various details. And just like the rest of our doc, whenever there's like a YouTube video or anything, we've got the links at the top right here that you can see. And we also have now separate pages for a number of common actions, things like creating a storage pool with detailed instructions for each of them. We've got information on instances, adding storage volumes, configuring limits, that kind of stuff, configuring storage settings on storage pools, interacting with the storage pools themselves, just listing volumes, and then the migration bits are here, backup of volumes. And one page that also took quite a bit of effort to clean up has been the how to resize storage. Now those were effectively just a few notes that we had here and there. Now we've got much clearer instructions for BRFS, LVM, and ZFS, which have their own instructions here. We actually have a goal to automate that part and make it API driven in the future, but for now, we've got much improved documentation for it. That's pretty much it for the documentation side of things. Now, the next, oops. All right. For the next feature, it's the consistent storage volume configuration, which probably not really worth demoing because it effectively just works the way you expect it to now. Actually, maybe I can just show back the documentation for this one. So if you go in documentation, I would expect that if you pick, say, BRFS or something, you can see here storage volume configuration, and those keys, if you prepend them with volume dot, which is what's kind of defined here, then you can set that on the storage pool, and whenever a new volume is created on that storage pool, the config will be set. And instead of like some keys supporting it, some keys not supporting it, some keys looking at the value on the pool instead of having it directly set on the volume, all that stuff has been cleaned up. It all works the same way now. It's actually the bit that's defined here with configure default values for storage volumes. It all works consistently in lxd 5.4. Alrighty. Now switching to a terminal for the last feature on the list, and that's the project support in lxd-benchmark. So you might have seen me demo lxd-benchmark in the last video. And well, now we've got a new configuration option here for project, passing the project name. So if I look at my local projects here, I'm currently in my default project, but I've got a project called demo, and it's currently empty. So let's just try to create. I actually need an image first. Does it use images? Yeah, it does. Okay. Image copy. So just copy that image as Alpine in the local, on the local server and in the project demo. Okay. So that should be fine. And now let's see, lxd-benchmark init. Say we want 10 instances of that. And the image is called Alpine. And the project is demo. Okay. So now if I list my demo project, instances are in there and that didn't go into my default project and pollute my default project. And more importantly, you don't have to be worried about running this particular command. Whoops, don't need for the C or for Alpine. So delete wipes all containers that have a name starting with benchmark. If you're a bit worried that this might accidentally delete stuff in projects you care about, it's really convenient to be able to pass in a different project, in which case you don't really have to worry about it. And that's it for lxd 5.4. It's currently rolling out to users. So for Snap users, we've put it in candidate on Friday. It's been the weekend there, and starting today, it's been rolling out to users, but it's a phased rollout that can take about 48 hours for everyone to get hit by it. And that's pretty much it. I'm just looking at the questions now in the chat. So this question, is it possible to set limit per target for the load balancer? No. We're effectively limited to whatever features Oven load balancer support, and they're not supporting a lot of features there yet. Where like one thing we would have liked to see is more active monitoring of the backends. So effectively checking that the backends are alive, that they're working properly, and then send traffic to only to backends that are properly responding. Oven does have something that's supposed to do that, but we couldn't make it work, so it's currently not in there. We expect to add that in the future as soon as we manage to get Oven to behave. And similarly, Oven, as far as I know, just does basic hashing of kind of client, source and destination addresses, and then send traffic that way. It doesn't itself keep any kind of counters to know any amount of traffic or amount of requests that have been sent to any particular backend. So that's not super flexible. It would be a lot more flexible if we were to deploy and manage something like HA proxy, but then that would be a quite large external dependency and quite problematic to integrate with something like Oven. So currently quite limited. We're hoping that the Oven folks will be putting more effort into it, and then we can surface those features as they become available. Can backend targets added remove dynamically via the API? Yes. So in this case, I did it with just the through the edit command, which is not the most scriptable thing. But if you go look at network load balancer, you've got subcommands for backends here that can do add and remove, and you do have same thing for ports with add and remove. So you can script that if you want, or you can just do it through the API instead, so through our REST API or through any of the bindings that exist. One thing that's worth kind of reminding folks about, so let me just switch to the actual deployment that has one. So if I do network load balancer, let's default. Yeah, that shows our load balancer. And then I can do load balancer, say backend add blah, and I guess I need the address. So it's probably listen address, I think it was 1, 2, 3, 4, and then that would probably take here network name and load balancer name. I would expect something like that. Invalid target address for backend, blah. Okay. Oh, I guess it needs to be within the subnet. Okay. Well, it's going to be a bit weird if I redefine one that already exists, but let's do that. Nope. Okay. Is it complaining because I already have one of those? Oh, it's actually not this address, it's target address. I think that's the issue. Anyway, I'll create a new container and then we'll make the traffic go that way because that makes more sense. Okay. So let's do target address instead and go to 6. No? Okay, what am I doing wrong now? Load balancer, edit on defaults. Okay, target address. Okay. I guess I should read the help real quick. Backend add. Okay, so backend add network, listen address, backend name. Oh, okay, it just takes the target address directly. That's why. Okay. Target address and then target port. Okay, that makes sense. That actually makes it shorter. And that way, if we do a show on default, so default network and the load balancer, we should see that we've got a new backend that's been defined. Here's blah. Then for the port, I think the CLI doesn't actually let you modify it directly, but you would need, so you effectively need the script deleting it and adding it back, which in this case would be default 4545 14253, and then protocol and listen port. So it's TCP and the listen port was say 1234. So that would remove it, and then we do add TCP 1234, and it's probably either like comma separately list or something like that. So U1, U2, U3, U4. Receiver target backend. Okay, so I guess no. How does that work? Okay, protocol listen ports, yes. Backend name, comma backend name. Okay, so that should have worked. U1, U2, U3, U4. Invalid target. Oh, it's because it's not called U4, it's called blah. There we go. Okay. Sorry, it's mostly me not having played with those commands yet, but that way you actually remove the port definition and you add it back. If you wanted to do this more atomically, you can do it through the API. It's just not, the CLI doesn't expose it unless you go through edit. But one thing that's worth keeping in mind with lxd is you can always do --debug, and then you can see what it did. So in this case, you can see that it updated the record with the new definition. And when I do add, same deal, it's just gonna push a new list of ports. So you can, through the API, do the put and alter either the list of backends or the list of ports dynamically, and that will work just fine. All right. I think that's it for questions. So yeah, thanks very much for watching this. Thanks very much for using lxd. We've got more very exciting features coming up in lxd 5.5. You can actually go and watch. There is a video I made, I think I published a couple of weeks ago, that goes through the main features we're working on up until the end of our current development cycle, so October-ish. And yeah, next cycle we expect, well, in lxd 5.5 we're expecting to have things like the ready state should be in there. Hopefully the object storage will be in there. We might have InfiniBand for virtual machines. Quite a lot of stuff are now getting ready, like the specifications exist and are now getting implemented and will be landing over the next few weeks. So pretty exciting. Hope that lxd 5.4 works for everyone. That's not too bumpy because of the vsock API change we had to make. And I see you all in another live stream or in the next video. Bye.